What if I told you that scientists have now given robots a real brain that costs less than a high-end smartphone? That machines may soon help us grow babies in artificial wombs, and that doctors are using viruses not to make us sick, but to cure cancer? This past year has delivered some of the most jaw-dropping discoveries in robotics, medicine, and space science. Let's explore the breakthroughs that are reshaping our world and redefining the future. The rise of smarter robots. One of the most exciting announcements came from NVIDIA, which unveiled the Jetson AGX Thor, a robot brain powerful enough to run multiple AI models at once with lightning-fast speed. What makes this breakthrough remarkable is that it's affordable, costing only a few $1,000s. This means advanced robots capable of real-time vision, speech, and decision-making will no longer be limited to billion-dollar labs or secret research facilities. Developers everywhere can start building robots that can see, think, and react, just like us. At the same time, a company called Skilled AI introduced a general-purpose robot brain designed to work on almost any kind of machine. Until now, most robots had to be programmed for very specific environments. If you built a warehouse robot, it would struggle to walk upstairs or pick up objects it wasn't trained for. Skilled's new model changes that. It allows robots to adapt to their surroundings, whether that means navigating messy environments, recovering after being pushed, or performing new tasks on the fly. Researchers have also created algorithms that allow robots to experience something close to regret. When a robot makes a mistake that could put a person in danger, it can now evaluate its decision and adjust its behavior in the future. It's a step toward robots that are not just efficient, but safe and considerate of the humans they work alongside. Meanwhile, humanoid robots are becoming more advanced and lifelike. Tesla's Optimus robot is now capable of handling delicate objects like eggs, moving with balance and grace, and even performing yoga poses. Hyundai and Toyota are developing robots designed to work inside factories and homes, moving with agility once thought impossible. South Korea has even launched a national alliance dedicated to developing humanoid robots by 2030, with a focus on shared AI and hardware standards that will make large-scale deployment more practical. Robots. That reason. Until recently, robots have excelled at repetition but struggled with planning. Packing a box or organizing a shelf might seem simple to us, but for a robot, these tasks involve countless possibilities. MIT researchers have now developed algorithms that let robots evaluate thousands of potential actions in seconds, choosing the best path much like a human would. This kind of reasoning will be transformative for logistics, manufacturing, and even home assistance. Robots are moving from blind execution to true problem-solving. Soft and gentle machines. Not all robots are made of rigid metal. This year saw major progress in soft robotics. Machines made of flexible materials that can bend, stretch, and even mimic the movements of living organisms. Inspired by the mantis shrimp, some soft robots can gently stroke fragile objects or jump with surprising force. Others are being designed as soft exosuits, wearable devices that help people walk, run, or recover from injury without restricting natural motion. These machines could transform fields ranging from surgery to space exploration, where flexibility is more important than brute strength. Medicine reimagined. Perhaps the most startling medical announcement of the year came from researchers in China, who revealed prototypes of pregnancy robots designed to grow babies in artificial wombs. These systems simulate the environment of the uterus, providing nutrients, oxygen, and controlled growth conditions. While the technology is still experimental, it could one day provide new hope for couples facing infertility or premature birth. It also raises deep ethical questions about the future of reproduction and what it means to be born. In neurotechnology, brain-computer interfaces made dramatic progress. A wireless implant called NEO allowed paralyzed patients to regain the ability to control their hands, feed themselves, and use digital devices. This technology is moving us toward a future where thoughts alone can control machines, giving independence back to those who have lost mobility. Viruses as medicine. In cancer research, scientists advanced the use of oncolytic viruses, specially engineered to infect and kill cancer cells while sparing healthy ones. Early trials showed that these viruses can shrink aggressive tumors and stimulate the immune system to fight back. It's a stunning twist. Viruses that once terrified humanity may become powerful allies in the fight against cancer. Building organs in the lab. The dream of creating replacement organs took a leap forward as scientists grew the most advanced lab-made kidneys yet, complete with blood vessels and filtering structures. While still not ready for transplants, these kidney organoids represent a path towards solving the global organ shortage. Instead of waiting years for a donor, patients of the future may one day receive a new organ grown from their own cells. Another breakthrough came in 3D bioprinting. Hospitals in Europe used printers to create bone implants from calcium-based materials that fuse with the patient's skeleton. In some cases, patients were walking within weeks after surgery. The ability to print custom bones and implants on demand could revolutionize trauma care and orthopedic surgery. Editing genes to heal. CRISPR gene editing continues to deliver on its promise. This year, scientists corrected a mutation in retinal cells responsible for a form of inherited blindness. In early human trials, some patients regained the ability to perceive light after living in darkness. It's one of the first examples of gene editing directly restoring a sense that had been lost. The same technique could eventually be used to treat countless genetic disorders, rewriting the code of life to remove disease at its source. AI and early detection artificial intelligence has also begun to transform how we detect disease. New AI-powered blood tests are capable of spotting cancer markers, proteins linked to Alzheimer's, and even early signs of Parkinson's years before symptoms appear. This technology could shift medicine from treating illness after it develops to preventing it entirely, catching diseases in their earliest stages when they are easiest to fight. Imagine having a simple blood test in your 20s that gives you the tools to protect your health decades into the future. Slowing down. Aging. One of the most fascinating areas of research this year focused on longevity. In experiments with mice, scientists reprogrammed cells to a younger state, reversing some of the effects of aging without destroying their identity. The mice lived longer and healthier lives. The implications are enormous. If aging is just another process written in our biology, then perhaps one day it can be slowed, paused, or even reversed in humans. Aging may no longer be seen as inevitable, but as a challenge that science can overcome. The universe still surprises us. While robots and medicine dominated headlines, the universe itself revealed some remarkable surprises. Astronomers using the James Webb Space Telescope discovered a previously unknown moon orbiting Uranus. Though only about 10 kilometers wide, its existence reshapes our understanding of how Uranus formed and why its system of moons is so unusual. Another discovery came from a comet called 12P Ponce Brooks, also known as the Devil Comet. Scientists found that its water has the same hydrogen signature as Earth's oceans. This provides powerful evidence that comets may have delivered much of the water that makes our planet habitable. Every glass of water we drink may trace its origins to icy visitors from space billions of years ago. In the Butterfly Nebula, Webb revealed crystalline structures and rare carbon molecules drifting in the clouds of gas. These gem-like crystals may be precursors to the building blocks of life, suggesting that the seeds of biology are scattered across the galaxy in places we once thought were lifeless. Hidden secrets of Earth. Closer to home, ocean explorers discovered the Kunlun hydrothermal system near New Guinea, a massive field of underwater vents larger than any ever seen before. These towers release hydrogen-rich water and support thriving ecosystems of shrimp, worms, and microbes. Such environments may resemble the cradle where life first began on Earth. Meanwhile, scientists finally solved a mystery that has puzzled humanity for centuries: how lightning actually begins. By studying electrical avalanches inside storm clouds, they discovered that runaway electrons create bursts of X-rays and gamma rays just before a bolt strikes. This explains why lightning is hotter than the surface of the sun, and it may help us better protect aircraft and power grids in the future. In Greenland, researchers reopened sediment samples that had been drilled out of the ice back in the 1950s, but forgotten for decades. These ancient soils contained plant fossils and climate clues proving Greenland was once ice-free and green. It's a warning that Earth's climate can change dramatically and faster than we might expect. Technology at the frontier technology didn't stand still either. Scientists created an optical computing chip that processes data using light instead of electricity. By harnessing multiple wavelengths simultaneously, this chip can perform massive computations with very little energy. Thanks for watching.
Look up at the night sky for just a moment. What do you see? Tiny twinkling lights scattered across a black canvas. But the truth is, those lights hide a reality so mind-bending that no science fiction story could come close. Tonight, we're diving into 25 space facts that will blow your mind. From stars that make our sun look like a candle, to planets so bizarre they shouldn't even exist, to the terrifying fate of the universe itself. Stick around, because fact number 25 will remind you that everything you are once came from the heart of a dying star. Fact 1. The age of everything. The universe is around 13.8 billion years old. That number is almost impossible to comprehend. Imagine shrinking the entire history of the universe into a single calendar year. The Big Bang happens on January 1st. Galaxies form in spring. Dinosaurs don't appear until Christmas morning. And humans, we arrive in the last minute of December 31st. Every empire, every war, every invention, just a blink. Fact 2. Stars beyond imagination. There are more stars in the universe than grains of sand on Earth's beaches. Astronomers estimate around 200 billion trillion stars. That's 200 septillion blazing suns. Imagine standing on a beach, picking up a single handful of sand, and realizing each grain could represent an entire solar system. Fact 3. Crossing the universe is impossible. The observable universe is 93 billion light-years across. Even if you could travel at the speed of light, the ultimate cosmic speed limit, it would take you longer than the current age of the universe to reach the edge. And beyond that, we don't even know how far it stretches. Fact 4. Silence of the cosmos. Space is completely silent. Sound needs something to travel through. Air, water, anything. But in the vacuum of space, there's nothing. Imagine standing next to an exploding star. It would outshine entire galaxies, but you'd never hear a sound. Fact 5. The sun, our quiet giant. Every second, the sun converts 600 million tons of hydrogen into helium. That's enough energy to power all of human civilization for millions of years. Yet in cosmic terms, our sun is completely ordinary. Just one average star among billions. Ordinary stars may give us life, but extraordinary stars can bend the very fabric of reality. Fact 6. The largest star. The giant known as UY Scuti is more than 1,700 times the size of our sun. If it replaced the sun in our solar system, its edge would stretch past Jupiter's orbit. Earth, Mars, and the asteroid belt would all be swallowed whole inside a single star. Fact 7. The densest objects. When massive stars die, they sometimes collapse into neutron stars. They're so dense that a teaspoon of their material would weigh billions of tons. Drop that on Earth and it would smash straight through the crust into the core. Fact 8. The ultimate monsters. And then there are black holes, places where gravity is so strong that not even light can escape. If you fell into one, you wouldn't just be crushed, you'd be stretched, atom by atom, into something scientists grimly call spaghettification. Fact 9. Danger close. The nearest known black hole isn't in some distant galaxy. It's just 1,600 light-years away. In the grand scale of the cosmos, That's practically next door. Fact 10. Breaking time itself. Black holes don't just trap matter, they trap time. To an outside observer, you would appear frozen forever at the event horizon, while the rest of the universe kept racing ahead. In theory, if you fell in, you could see the future of the universe unfold in front of your eyes before you were gone. But not all of space's nightmares are hidden in black holes. Some are sitting quietly, disguised as planets. Fact 11. The diamond world. There's a planet called 55 Cancri E that may be made mostly of diamond. Imagine a world sparkling with trillion-carat riches, orbiting its star in a fiery inferno just 40 light-years away. Fact 12. Shards of glass in the wind. On HD 189733b, it literally rains glass. Winds blow molten shards sideways at 4,000 miles per hour. If you stood there, you'd be shredded instantly by a storm of knives. Fact 13. The Wanderers. Some planets don't orbit stars at all. They're called rogue planets, drifting endlessly through the dark void. No sunrise, no warmth, just eternal, frozen night. Fact 14. Eaten alive. On WASP 12b, the planet orbits so close to its star that the star's gravity is tearing it apart. Within 10 million years, WASP 12b will be completely devoured. A planet destroyed by the very thing that gave it life. Fact 15. The King of Giants. Jupiter isn't just big, it's dangerous. Its magnetic field is 14 times stronger than Earth's, and it's surrounded by radiation so deadly it would kill a human in minutes. Yet without Jupiter, Earth might not. Our solar system may feel familiar, but the deeper you look, the stranger it becomes. Section 4. The solar system you thought you knew. Fact 16. Saturn's vanishing beauty. Those stunning rings, they're temporary. NASA has discovered they're slowly raining down onto Saturn. In about 100 million years, Saturn will lose its crown. Fact 17. A day longer than a year. On Venus, one rotation takes 243 Earth days, but it only takes 225 days to orbit the Sun. That means a single sunrise on Venus lasts longer than an entire Venusian year. Fact 18. The fastest winds. Neptune's atmosphere hosts winds that reach 1,200 miles per hour. That's faster than the speed of sound on Earth, enough to tear apart steel. Fact 19. Olympus Mons, the giant. Mars is home to Olympus Mons, the largest volcano in the solar system. It stands 3 times taller than Everest, and its base is so wide it could cover the entire state of Arizona. Fact 20. The terrifying spin stop. If Earth stopped spinning, even for a second, everything on the surface would be flung eastward at 1,000 miles per hour. Oceans would crash over continents. Cities would collapse. The planet would be torn apart. Mini hook. And if that sounds terrifying, wait until you hear about the universe itself. Section 5. The mysteries of the cosmos. Fact 21. The invisible glue. Dark matter makes up 27% of the universe. We can't see it, touch it, or measure it directly, but without it, galaxies would fly apart. It's the invisible glue holding the cosmos together. Fact 22. The force of expansion. Even stranger is dark energy, a mysterious force making up 68% of the universe. It's pushing galaxies away from each other faster and faster, stretching space itself. Fact 23. The lonely future. If this expansion continues, billions of years from now, the night sky will look empty. Distant galaxies will have drifted so far away that not even light can reach us. Future civilizations might never know they existed at all. Fact 24. Time is not equal. Einstein proved that time slows down near strong gravity. We've even tested it. Identical atomic clocks, one on a mountain, one at sea level, tick at different speeds. On Earth, the effect is tiny, but near a black hole, it could mean the difference between hours for you and centuries for everyone else. Fact 25. The coming collision. In about 4 billion years, our Milky Way will collide with the Andromeda Galaxy. Stars will be ripped from their orbits. New stars will ignite, and our solar system will drift into an entirely new galaxy. The night sky will look unrecognizable. The universe is vast, terrifying, and beautiful all at once. From planets that rain glass, to black holes that warp time, to the mind-bending mysteries of dark matter and dark energy, we are surrounded by wonders we're only beginning to understand. And here's the part that should truly blow your mind. Every atom in your body was forged in the heart of a dying star. You are literally made of stardust. So next time you look up at the night sky, remember, you're not just looking out into space. You're looking into the very story of where you came from. Which of these facts shocked you the most? Let me know in the comments below. And if you enjoyed this cosmic journey, make sure to hit subscribe, because this is just the beginning.
What if I told you the first human who will live to be 1,000 years old may already be alive today? Immortality has always sounded like science fiction, but right now, scientists across the world are working on ways to dramatically extend the human lifespan. Some believe death is inevitable. Others argue that aging is just a disease, and diseases can be cured. So the question is no longer just, can we live longer? But will humans ever live forever? Part 1. Humanity's oldest dream. For as long as humans have existed, we've feared death and dreamed of immortality. Ancient myths spoke of magical waters like the fountain of youth. Alchemists searched for the philosopher's stone, hoping it would grant eternal life. Powerful emperors sent expeditions to find hidden elixirs, desperate to escape mortality. But while the ancients had only stories and superstition, modern science has something much more powerful: data, biology, and technology. And this is where the story of real immortality begins. Consider this. Just 200 years ago, the average life expectancy on Earth was only around 35 years. Today, in many countries, people regularly live beyond 80. In less than 2 centuries, humanity has already more than doubled its expected lifespan. If we've come this far in such a short time, how much further could we go? Part 2. The science of aging. Aging may feel natural, but biologists see it differently. To them, aging is a process of damage. Every time a cell divides, small errors build up. DNA becomes damaged. Proteins misfold. Telomeres, the caps on the ends of chromosomes, shorten, like the plastic tips on shoelaces wearing down. Eventually, the system begins to fail. But what if we could stop or even reverse this process? In 2019, scientists published research showing that they had successfully lengthened telomeres in human cells in the lab. This effectively made old cells young again. Other experiments in mice have extended lifespan by as much as 30%. Aging, once thought to be unstoppable, is now being treated like a disease. Part 3. The rise of longevity science. The fight against aging has now become one of the most heavily funded areas of medical research. Tech billionaires are pouring billions into what they call life extension. Companies like Calico Life Sciences and Altos Labs are experimenting with cellular reprogramming. By resetting certain genes, they hope to return old cells to a more youthful state without losing their identity. Imagine a treatment where a 90-year-old person could walk into a clinic, take a therapy, and walk out feeling 30 again. Other researchers are exploring nanotechnology, tiny molecular machines that could one day repair cells, remove toxins, and fix DNA damage in real time. In theory, such technology could keep a body in a permanent state of health. This is not fantasy. Laboratories are already testing the first steps of these ideas. Part 4: Cryonics and Freezing the Future. But what if science doesn't crack the code soon enough for us? That's where cryonics comes in. Cryonics is the process of freezing a body, or even just the brain, in liquid nitrogen after death. The hope is that one day, future medicine will be able to revive and repair them. Companies like Alcor in Arizona already store hundreds of patients in this frozen state. Critics argue it's wishful thinking, but to those who sign up, it's not about certainty, it's about possibility. As cryonics advocates like to say, being frozen isn't being dead. It's being in the waiting room for future medicine. Part 5: Genetic Engineering and DNA Tweaks. Another path to immortality is written directly in our DNA. Using CRISPR gene editing, scientists can now cut and paste genetic code with remarkable precision. This allows them to silence harmful genes, enhance protective ones, and potentially remove the root causes of aging altogether. In animal studies, tweaking certain genes has already extended lifespan dramatically. In worms and mice, life has been extended by 30 to 50%. While humans are far more complex, the principle is the same. If we can identify the genes that control aging, we may be able to reprogram them to give us centuries of life. Part 6: Digital Immortality. But what if immortality doesn't mean keeping the body at all? Some futurists believe the real path lies in uploading the mind into machines. Your brain contains about 86 billion neurons, each connected to thousands of others, forming trillions of connections. If we can one day map and simulate this network, we could, in theory, copy a human mind into a computer. Ray Kurzweil, a famous futurist, predicts this could happen by the end of the century. Imagine living forever as a digital consciousness, free from disease, free from aging. You could explore virtual worlds, or even inhabit robotic bodies that travel to the stars. But this raises profound questions. If a digital copy of you exists, is it truly you? Or just a simulation with your memories? Would you feel continuous life, or would your consciousness end the moment the upload begins? Part 7: Immortality and its Problems. Even if science makes immortality possible, humanity will face serious challenges. What happens to the planet if no one dies? Would overpopulation spiral out of control? Would immortality only be available to the wealthy, creating an elite class of forever people while others still age and die? And perhaps the deepest question, if you replace your cells, your genes, and even your brain, are you still you? Or are you just a copy wearing the mask of your old self? This is known as the ship of Theseus problem. If every plank of a ship is replaced, is it still the same ship? Immortality forces us to face this paradox head-on. Part 8: Are we already on the path? Some scientists, like Dr. Aubrey de Grey, argue that the first person to live 1,000 years has already been born. His idea is that if science can extend life even a little each year, eventually each new breakthrough will buy enough time for the next one. He calls this longevity escape velocity. Others are more skeptical, arguing that the complexity of biology makes true immortality impossible. But even the skeptics admit that life extension is advancing rapidly. Living to 150, 200, or perhaps even 500 years may not be science fiction. It may be science in progress. Part 9: The Cosmic Perspective. Now imagine combining immortality with space travel. If you could live for centuries, you could travel to distant stars, watching civilizations rise and fall across the galaxy. Immortal astronauts could colonize entire worlds, becoming witnesses to the far future of the universe. Living forever wouldn't just change your life, it would change the destiny of our species. Humanity could survive disasters spread across the stars, and even outlive our planet. Part 10: Conclusion and Big Question. So, will humans ever live forever? The truth is, we don't know. But what's clear is that science is pushing the boundaries of life in ways our ancestors could never have imagined. Whether through genetics, nanotechnology, cryonics, or digital minds, humanity is closer than ever to making death optional. But maybe the real question isn't if we will live forever. The real question is, should we? Because living forever could give us infinite possibilities, but it could also change what it means to be human. Expansion Section 1: The Science of Cellular Repair. When we think about aging, we often imagine wrinkles, gray hair, and aching joints. But beneath those visible signs, there is a hidden battle happening inside every cell. Proteins fold the wrong way. Mitochondria, the power plants of the cell, begin to sputter. The immune system becomes confused, sometimes attacking the body itself. Scientists call this the hallmarks of aging, a set of biological processes that slowly erode our vitality. But here's the exciting part. Each of these hallmarks can potentially be targeted with treatments. Already, researchers are testing drugs called senolytics, which are designed to hunt down and destroy old, malfunctioning cells that clog up the body. In mouse experiments, removing these zombie cells not only extended lifespan but restored physical health, making elderly mice act young again. Imagine what that could mean if applied to humans. Expansion. Section 2: Lessons from Nature. The natural world is full of creatures that challenge our ideas about aging. The Greenland shark, for example, can live more than 400 years, making it the longest living vertebrate on Earth. Some tortoises survive for centuries, and certain jellyfish can actually reverse their aging process, returning to a juvenile state after reaching maturity. These examples suggest that nature already contains the secrets of extended life. By studying these species, scientists hope to unlock genetic blueprints that might one day be applied to humans. If a jellyfish can reset itself and live forever in the ocean, could we one day do the same? Expansion Section 3: The Role of Artificial Intelligence. Artificial intelligence may play a key role in the quest for immortality. Today's AI systems can sift through mountains of biological data faster than any human, spotting patterns that might take decades to notice. Machine learning is already being used to design new drugs, predict how cells respond to treatments, and even simulate the process of aging at the molecular level. Some experts believe AI will be the ultimate partner in longevity research, helping us accelerate discoveries that would otherwise take centuries. If AI can crack the code of aging, humans might not just live longer, but live better, with personalized treatments that keep our bodies in peak condition for hundreds of years.
Space is vast, mysterious, and stranger than we can possibly imagine. Some of the most unbelievable facts about our universe sound more like science fiction than reality. Did you know there are planets where it rains molten glass sideways at 7,000 kilometers per hour? Or that the largest known star could swallow our entire solar system? Today, we are diving into the most mind-bending and jaw-dropping space facts ever discovered. By the end, you will see the universe in a completely different way. Let's start with something that defies common sense. The universe has no center. When we think of an explosion, we imagine debris flying outward from a central point. But the Big Bang wasn't an explosion in space. It was the expansion of space itself. Every galaxy is moving away from every other galaxy, like raisins in rising bread dough. That means no matter where you stand in the universe, it looks like you're at the center. The reality is there is no single middle of the universe. Everywhere is expanding at once. Now let's move to something even larger than the universe itself expanding, the largest known star. Its name is UY Scuti. This monster is so gigantic that if you replaced our sun with UY Scuti, its surface would extend beyond the orbit of Jupiter. That's over 1,000 times the size of our sun. You could fit more than 5 billion suns inside it. Yet despite its unimaginable scale, it appears as nothing more than a faint dot through our most powerful telescopes. It is a perfect reminder of just how small our solar system really is. As if that wasn't wild enough, there's a planet made almost entirely of diamond. It's called 55 Cancri A, located about 40 light years away. Scientists believe it is largely made of carbon, And under the crushing pressures deep inside, much of that carbon could be crystallized into diamond. Imagine a world twice the size of Earth, glittering like a gemstone, worth more than anything humanity has ever known. Of course, with surface temperatures reaching 2,400 degrees Celsius, it's not exactly a place you could take a vacation. If diamonds don't impress you, how about alcohol clouds floating in space? Astronomers have discovered a massive gas cloud near the constellation Aquila, containing enough ethyl alcohol to make 4 trillion pints of beer. That's enough to give every person on Earth a glass every day for millions of years. It's floating in deep space, far beyond our reach, but it shows that the building blocks for complex chemistry are spread throughout the cosmos. Let's talk about something darker: black holes. These cosmic monsters are so dense that not even light can escape them. If you fell into a black hole feet first, your body would be stretched like spaghetti in a process scientists call spaghettification. Yet at the same time, from the perspective of an outside observer, you would appear to freeze in place at the event horizon. Time itself behaves differently depending on where you are. In a very real way, black holes warp the fabric of reality. But black holes are not the strangest things out there. Some stars, called neutron stars, are so dense that a single teaspoon of their material would weigh as much as Mount Everest. These stars are the collapsed cores of supernovae. They spin hundreds of times per second and generate magnetic fields trillions of times stronger than Earth's. Standing near one would be impossible. The sheer gravity would crush you instantly. And then there are rogue planets. These are worlds that drift through space without a star. They were once part of solar systems, but were flung out by gravitational chaos. Imagine a lonely planet, drifting endlessly through the darkness, with no sun to warm it. Some of these planets might still have internal heat, and even oceans beneath their frozen surfaces. It's possible that life could exist on one, floating in the void between stars. Here's another fact that doesn't feel real. There are more stars in the universe than grains of sand on every beach on Earth. Let that sink in. Pick up a handful of sand. Each grain represents a star. Now imagine every beach, every desert, every sand dune on Earth. Multiply that by thousands, and you might begin to grasp the scale of the cosmos. The night sky that looks almost empty is actually overflowing with uncountable stars. And around those stars orbit unimaginable planets. We've already discovered over 5,000 exoplanets, and we are only scratching the surface. Many are stranger than anything in science fiction. There's one where it rains molten iron, another where winds blow at 7,000 kilometers per hour, hurling shards of glass sideways. Some orbit so close to their stars that a year lasts only a few hours. Others are so far out that a single orbit could take 1,000,000 years. And around those stars orbit unimaginable planets. We've already discovered over 5,000 exoplanets, and we are only scratching the surface. Many are stranger than anything in science fiction. There's one where it rains molten iron, another where winds blow at 7,000 kilometers per hour, hurling shards of glass sideways. Some orbit so close to their stars that a year lasts only a few hours. Others are so far out that a single orbit could take 1,000,000 years. Then there's the concept of time itself in space. Time does not tick at the same rate everywhere. Einstein's theory of relativity tells us that the closer you are to a massive object, the slower time moves. This is called time dilation. Astronauts on the International Space Station actually age slightly slower than we do on Earth because they are moving so fast in orbit. It's only a fraction of a second, But it proves that time is not universal. It bends, stretches, and twists with gravity. Speaking of bending, light itself can be bent by gravity. Massive galaxies can act as cosmic magnifying glasses, bending and focusing the light of objects far behind them in a phenomenon called gravitational lensing. Thanks to this, we can sometimes see galaxies that are billions of light years away, magnified and distorted by invisible cosmic forces. Space literally lets us peer into the past. And speaking of the past, did you know that when you look at the night sky, you are seeing history? The light from our sun takes 8 minutes to reach Earth. The light from the nearest star system, Alpha Centauri, takes more than 4 years. The light from the Andromeda Galaxy takes over 2 million years. When you gaze at distant galaxies through a telescope, you're looking at them as they were millions or even billions of years ago. The deeper into space we look, the further back in time we see. Here's another fact that boggles the mind. The largest structure in the observable universe is a cosmic wall of galaxies stretching over 1.5 billion light years across. That's so enormous that if you traveled at the speed of light, it would still take you 1.5 billion years to cross it. Space is not just empty. It is filled with colossal structures held together by gravity, stretching across unimaginable distances. Finally, let's end on something close to home. Earth itself is not permanent. In about 5 billion years, our sun will run out of fuel and swell into a red giant engulfing Mercury, Venus, and possibly Earth. Long before that, humans will need to find a new home if we want to survive. Space is not just something out there, it is our future. It holds both our greatest dangers and our greatest opportunities. The universe is stranger, bigger, and more unbelievable than we could ever have imagined. From diamond planets to alcohol clouds, from rogue worlds to black holes, every discovery reminds us how small we are and how much there is left to explore. The only limit to what we will uncover next is how far we are willing to look.
What if alien life already exists? And we've been looking right at it without recognizing it. Most of us imagine aliens as green little beings, walking, breathing, and thinking a bit like us. But what if real alien life looks nothing like Earth? Nothing like biology as we know it? Today we'll explore the cutting-edge science and research into the possibility of life beyond carbon. Part 1. Our assumptions about life. When scientists search for aliens, they usually start by looking for planets like Earth. Why? Because our planet is the only example of life we know. We depend on water, carbon, and DNA. So naturally, our telescopes search for rocky planets in the habitable zone, where liquid water could exist. But here's the problem. If life can form in ways completely different from ours, we might be ignoring the vast majority of living worlds. What if alien life doesn't drink water, breathe oxygen, or even use carbon at all? Part 2. The case for carbon life. Carbon is special. It can form 4 strong chemical bonds, making it incredibly flexible. It's the Lego block of biology, able to build proteins, DNA, and cell membranes. That's why life on Earth is carbon-based. But carbon isn't the only element capable of complex chemistry. And that's where things get really interesting. Part 3. Silicon, the popular alternative. Some scientists think silicon could be the backbone of alien biology. Silicon sits right below carbon on the periodic table, meaning it shares similar chemical properties. It can form long chains and complex molecules, just like carbon. In fact, science fiction writers have long imagined silicon-based aliens, perhaps crystal-like beings, living in environments too extreme for us. NASA researchers have even suggested that in high-temperature worlds, silicon chemistry could dominate. Imagine aliens not made of flesh and blood, but shimmering crystal creatures walking across volcanic landscapes. Part 4, Life Without DNA. But what if aliens don't use DNA at all? Here on Earth, DNA and RNA store instructions for life. But scientists have created xenonucleic acids, synthetic molecules that can also carry genetic information. This shows that DNA isn't the only game in town. Life elsewhere could use completely different biochemistry to store its blueprints. If aliens don't use DNA, even if we brought one into a lab, would we even recognize it as alive? Part 5. The search for weird life. Astrobiologists call this idea weird life. Not little green men, but organisms so different from us they might not even register on our instruments. NASA's Astrobiology Institute has actually funded projects specifically to explore weird life. For example, in 2010, a controversial study claimed bacteria in California's Mono Lake could incorporate arsenic instead of phosphorus into their DNA. The claim was debated, but it opened the door. Maybe Earth itself already hides alien-like chemistry. Part 6, Moons as Alien Worlds. When we think of alien life, we imagine planets. But some of the best candidates are actually moons. Europa, a moon of Jupiter, hides a global ocean beneath its icy crust. Enceladus, orbiting Saturn, shoots water geysers into space. Both could host life very different from ours. NASA's upcoming Europa Clipper mission will dive into this mystery, searching for chemical fingerprints of alien biology. If we find even a single microbe under the ice of Europa, it would change science forever. Part 7. Life in Extreme Conditions. Here's the twist. Earth itself already shows us how weird life can be. Microbes called extremophiles live in boiling acid pools, deep ocean vents, and even inside nuclear reactors. Tardigrades, tiny water bears, can survive being frozen, boiled, starved, and blasted into space. If life can survive in such insane conditions here, why not out there? Part 8. Beyond Chemistry. Energy beings? Some researchers go even further. They suggest alien life might not be biological at all. Could plasma clouds or even electromagnetic patterns qualify as living systems? If intelligence is about processing information, maybe alien minds exist in forms we can't touch, like conscious networks of particles. What if we've already met aliens, not in UFOs, but in the very fabric of physics itself? Part 9. The Fermi Paradox. Of course, if life is possible in so many ways, we run into a mystery. The Fermi Paradox. If the universe is full of life, where is everyone? One possibility is simple: we don't recognize them. They could be living right now in forms we mistake for geology, chemistry, or even just noise in our instruments. Part 10. The Future of Alien Research. Right now, telescopes like the James Webb Space Telescope are scanning exoplanets for biosignatures, chemical fingerprints, and atmospheres that might suggest life. But if aliens use different chemistry, we may need to completely rethink how we look for them. We often take Earth's recipe for life for granted. But imagine a world where ammonia, methane, or even liquid nitrogen replaces water as the solvent for biology. On Saturn's moon, Titan, rivers and lakes of liquid methane cover the surface. NASA scientists have speculated that if life exists there, it may swim not in water, but in liquid hydrocarbons. Instead of oily slicks being poisonous, they might be the cradle of life. What if Titan already holds alien life, but when we send probes, we dismiss it as just chemistry? Aliens on Earth? One of the most intriguing ideas is that alien life might already be here, hidden in plain sight. Astrobiologists have proposed the shadow biosphere hypothesis. The possibility that a second form of life, unrelated to our DNA-based biology, could exist on Earth right now. We may have missed it because our scientific tools are designed to look for Earth-like chemistry. If life used a different set of molecules, we'd simply filter it out as noise. Hook. Imagine scientists discover alien life not by looking into space, but by looking under a microscope in their own lab. The tools we're using to find life. The James Webb Space Telescope is already scanning exoplanet atmospheres for hints of gases like oxygen, methane, and carbon dioxide. These are considered biosignatures, gases that on Earth are produced by life. But what if alien biology creates gases we don't expect? We could scan right past signs of life because we're not looking for the right fingerprints. To prepare for this, researchers are building massive chemical libraries trying to catalog every possible molecule that life could produce, not just the ones we know from Earth. Historic UFO research and science beyond biology, there's also been renewed interest in unidentified aerial phenomena. While most of these cases likely have natural or human-made explanations, they push scientists to broaden the search. The Pentagon's UAP Task Force and Harvard's Galileo Project are trying to bring hard science to a subject once dismissed as fringe. Even if most sightings aren't evidence of alien visitors, the attention highlights the truth. We know shockingly little about what may share the universe with us. The scale of the universe. There are an estimated 200 billion stars in our galaxy alone, and at least 2 trillion galaxies in the observable universe. Even if only a fraction of stars host planets, and only a fraction of those host life, the numbers become staggering. To say that Earth is the only home to life begins to sound not just unlikely, but almost impossible. With numbers this vast, the question shifts. It's no longer, are we alone? It's, how crowded is the universe? Alien intelligence. If life is common, then intelligent life may also be out there. The famous Drake equation was created to estimate how many civilizations might exist in our galaxy. Depending on the assumptions, the number could be 0 or millions. Some scientists even suggest we may not notice alien intelligence because it could be machine-based. Civilizations older than ours might already have merged with technology, existing as planet-sized computer networks or energy beings beyond our comprehension. If alien civilizations are millions of years ahead of us, would we even be able to tell they exist? Or would they look like the very laws of physics themselves? Why haven't we found them yet? This takes us back to the Fermi paradox. If the universe is full of life, where is everybody? Possible answers include aliens may exist, but we're too primitive to detect them. They could be deliberately avoiding us, a concept known as the zoo hypothesis. Or maybe civilizations rise and fall so quickly on cosmic timescales that two rarely overlap. Each explanation is unsettling in its own way. The human angle. The search for alien life isn't just about them, it's about us. If we discover life that doesn't look like us, it forces us to rethink what life even means. It challenges religion, philosophy, and our place in the cosmos. And perhaps most importantly, it reminds us that life is resilient, creative, and boundless. So, will we ever find alien life? Probably yes, but it may not look anything like what we expect. Maybe it's carbon-based and familiar. Maybe it's silicon-based, crystalline, or digital. Or maybe it's so different we won't even recognize it at first. The universe is unimaginably vast, and life has had billions of years to experiment. The real question may not be whether life exists, but whether our human minds are ready to understand it when we finally see it. Final hook. And if aliens are already out there, maybe the real reason we haven't found them is because we don't even know what we're looking for.
Picture this, you're scrolling through old photos and suddenly you see someone holding a smartphone in a picture from the 1940s. Or you hear about a man who claimed he traveled from the year 2036 to warn us about the future. Wild conspiracy? Maybe. But here's the question, could there actually be truth to time travel? Today, we're diving into one of the most mind-bending ideas in all of science. Could time travel exist? And the answers will shock you because scientists have already proven that time doesn't work the way you think it does. Part 1. What actually is time travel? When most people think of time travel, they picture science fiction. A shiny machine, a push of a button, and suddenly you're in the age of the dinosaurs. But scientifically, time travel doesn't have to be that flashy. It simply means moving through time at a different rate than everyone else. And here's the crazy part. You're already doing it. Right now, this second, you are traveling through time. 1 second per second, straight into the future. The real question is, can we bend the rules to move faster, slower, or even backwards? Part 2, Einstein's shocking discovery. To find the answer, we need to rewind to 1905. That's when Albert Einstein shook the world with his theory of relativity. He showed that time is not a rigid, universal clock. Instead, it's flexible. It stretches and warps depending on your speed and the pull of gravity. Think about it like this. If space is like a giant trampoline, then time is stitched right into it. Put something heavy, like a planet, on the trampoline, and it bends. That bend doesn't just curve space, it curves time as well. Here's where it gets wild. If you move really fast, close to the speed of light, time for you slows down compared to everyone else. This isn't just theory, it's been tested, proven, and measured. Part 3, the proof. We've already done it. In the 1970s, scientists ran the Herschel-Keating experiment. They took 2 super-precise atomic clocks, set them to the exact same time, and put one on an airplane while the other stayed on the ground. After circling the globe, the flying clock had ticked just a little bit slower than the one left on Earth. Time itself had bent, and astronauts proved this too. Gennady Padalka, a Russian cosmonaut who spent more time in space than anyone else, 879 days, is about 0.02 seconds younger than the rest of us because of time dilation. That means he literally experienced less time than people on Earth. He time traveled into the future, just a tiny bit. So here's the truth. Time travel into the future isn't science fiction. It's real. It's already happening. The only limit is how much we can scale it up. Part 4. Time travel to the future, the speed of light. Here's where it gets mind-blowing. Let's say you board a spaceship that can travel close to the speed of light. For you, 1 year passes, but when you return to Earth, maybe 50, 100, or even 1,000 years have gone by. This isn't fantasy. This is what Einstein's math demands. It's called time dilation. The faster you go, the slower your clock runs compared to everyone else's. At the speed of light, your time could stand still entirely. If humans could ever build such a ship, you could leave Earth today, take a short trip, and return to find the world far, far into the future. Futuristic? Absolutely. Impossible? Not at all. It's already written into the fabric of reality. Part 5, the big question, can we go backwards? But going forward is only half the story. What about traveling back? Could you really go visit the dinosaurs or meet your younger self? This is where science gets complicated. Some solutions to Einstein's equations suggest that time loops are possible. Imagine bending space-time so much that it curves back on itself. In theory, that could allow you to step into your past. One of the most popular ideas, wormholes. These are shortcuts through space-time, tunnels connecting 2 distant points. If one end of a wormhole was accelerated to near light speeds and then brought back, the 2 ends could be in different times. Walk in one side, and you might walk out years earlier or centuries later. Part 6. The challenges of wormholes. There's just one small problem. Wormholes are ridiculously unstable. If they even exist, they'd collapse instantly before anything could pass through them. To keep one open, you'd need something called exotic matter, a form of matter with negative energy. And while negative energy has been observed in tiny quantum effects, we're nowhere near harnessing enough to hold a wormhole open. But here's the twist. Kip Thorne, a physicist who literally helped design the science behind the movie Interstellar, has written detailed papers on how a wormhole time machine might actually. He proved that, at least mathematically, it's not impossible. Part 7. The Paradox Problem. Even if we could build one, traveling backwards creates a huge headache. Paradoxes. Take the grandfather paradox. You go back in time and stop your grandparents from meeting. If they never meet, you're never born. But if you're never born, who went back in time to stop them? It's a loop that doesn't make sense. And then there's the bootstrap paradox. Imagine you go back in time and hand Shakespeare a copy of Romeo and Juliet. He publishes it, becomes famous. But you only knew about the play because you read it in school. Who actually wrote it? No one. The knowledge just exists in an endless loop. These paradoxes force scientists to wonder. Maybe the universe has rules we don't yet understand. Maybe paradoxes are impossible. Or maybe, and this is even stranger, the universe splits into multiple timelines every time you change the past. That's the idea behind the multiverse. Part 8. Why don't we see time travelers? Narrator. Here's the obvious question. If time travel to the past is possible, where are all the time travelers? Why hasn't someone from the year 4000 shown up to tell us what happens? Some scientists argue it's because you can only travel back to the moment the time machine was created. Meaning, if we built one tomorrow, people from the future could only come back to tomorrow, not before. Others suggest time travel may be happening right now, but in ways we can't detect. Or maybe the rules of the universe forbid travelers from changing anything important, which is why we never notice them. Part 9. Time travel experiments you've never heard of. Beyond relativity, scientists are also looking at time in the strange world of quantum physics. In 2014, researchers claimed they simulated a particle moving backwards through time inside a quantum computer. It wasn't a DeLorean, but it was a hint that time might be more flexible than we think. Another fascinating idea, the cosmic strings theory. These are hypothetical cracks in space-time left over from the early universe. If two of them passed by each other, they might create closed loops in time. In other words, natural time machines. Part 10. The verdict. So, could time travel exist? Here's what we know. Traveling into the future is absolutely possible. Einstein's math proves it, experiments confirm it, and astronauts experience it. The only limit is our technology. Traveling into the past, the equations say maybe, but paradoxes, instability, and the lack of exotic matter keep it out of reach, at least for now. Right now, time travel is a door that's cracked open. We know it's not locked, but stepping through it, that's the challenge. Outro, hook, to next video. But let me leave you with this. If time travel is possible, maybe we've already met time travelers without knowing it. Could strange events in history, inventions that appeared too early, mysteries we can't explain, actually be clues? That's a story for another video. Thanks for watching. If this journey through time bent your brain, hit like and subscribe for more science that changes the way you see reality. And tell me in the comments, if you had one chance to time travel, would you go to the future or the past?